You click a thumbnail, and within milliseconds, a high-definition video arrives on your screen from thousands of miles away. It feels like magic, but every trick has a mechanism. If someone decided to pull the plug and shut down the global internet today, whose hand would actually be on the switch? To understand how the web is governed, we have to look for the entity that wields ultimate control over the network. The internet relies on a sprawling physical infrastructure. This machine spans the entire planet, and we need to identify who is actually operating it. We can start with the most obvious power, the government. While they can block specific websites or throttle access within their own borders, these are local barriers. They possess no mechanism to shut down the global network itself. Then there are the local telecom companies. You pay your monthly bill to providers like Jio or Airtel, but they function as local distributors. They facilitate your connection, but they don't own the underlying architecture. Tech giants like Google, Facebook, and Amazon store the vast majority of our data, yet the web remains open. Anyone can launch an independent website without seeking permission from a Silicon Valley CEO. If the governments, telecoms, and tech giants are just participants in the system, we have to look deeper into the physical layers of the web to find where the true power lies. Those local telecom companies are classified as Tier 2 and Tier 3 ISPs. They function as a local delivery service, distributing access within specific cities or regions. The data they deliver is pulled from massive, high-security warehouses called data centers. These are physical buildings, packed with hardware, often owned and operated by the major tech firms. When you stream a video, that file is retrieved from a physical server inside one of these foreign warehouses, waiting to be sent across the globe. This creates a clear division. Tech companies own the warehouses, and local telecoms handle the final delivery to your home. But that leaves the question of who owns the international highways that connect them. Wireless internet is a bit of a misnomer. Your phone signal only travels through the air to the nearest cell tower. From there, the entire connection moves through physical cables underground. These connections lead to Tier 1 companies who spent billions laying heavy, physical cables across the ocean floor using specialized chips. This network was made possible by physicist Narinder Singh Kapani, who demonstrated that light could bend through a physical medium to create optical fiber. These cables contain glass strands as thin as human hair. Data travels as light, which stays trapped inside the glass by bouncing off the inner walls, a process called total internal reflection. This allows information to move at nearly the speed of light. These deep-sea cables eventually emerge at landing sites to connect with land-based networks. In India, much of the world's data enters through the Mumbai coastline. The internet is a tangible, physical web of glass crossing our oceans. Every byte of data depends on this heavy infrastructure. Even with a global network of cables, there is still a logistical hurdle. How does a single packet of light racing through an ocean cable find one specific smartphone among billions of devices? Every device has an IP address, a unique digital number functioning like a physical postal address. But since humans can't remember these numbers, the domain name system lets us type readable names like youtube.com, which the system translates back into the numeric IP. The organization with authority to assign these names and numbers globally is ICANN, based in Los Angeles. They manage the master directory linking every device. Without this central directory of IP addresses, the physical cables would just be a maze of lost data with no way to reach its destination. We can now see the full picture. Tier 1 companies own ocean cables, local ISPs handle the final mile, tech giants own the data centers, and ICANN manages the address book. This reveals a striking truth about the internet's leadership. There is no single person or entity in charge. The internet is owned by no one. The network is decentralized by design. Because different organizations own different interlocking pieces, the system is incredibly resilient. If one cable is cut or one server farm fails, the data automatically finds another route to its destination. The internet's strength lies in this shared ownership. It is a massive, collaborative engineering feat where no single corporation or government has the power to turn it off.
We tap a screen and video plays instantly. We've grown comfortable with the idea of the cloud, a term that suggests all human knowledge is floating in the air, detached from the physical world. It appears that local governments and internet providers dictate what we can see, blocking websites or throttling speeds at will. However, these local barriers are easily bypassed. A simple VPN tunnel proves that your local provider is merely one gatekeeper in a global network they do not fully control. If the internet isn't in the sky, and it isn't strictly tethered to your local telecom provider, where exactly is the data? Where does a video physically reside before it appears on your device? The internet relies on a massive physical infrastructure. It is a machine of glass and steel hidden in the soil beneath our streets and resting on the floor of our oceans. Every website and video lives inside a physical warehouse known as a data center. These buildings house millions of server racks. These are high-powered, always-on hard drives that store and serve data the moment you request it. To move this data across the globe, continents are stitched together by massive cables laid across the bottom of the ocean. This entire system is built on the work of Indian scientist Narendra Singh Kapani. He pioneered the technology of optical fiber, which allowed us to transmit information through light. Inside glass as thin as a human hair, data travels via light. This diagram shows total internal reflection, where light bounces off the inner walls at nearly 300,000 kilometers per second without leaking out. Your phone might feel wireless, but every click you make triggers a physical journey through these underwater glass tubes. Speed is only half the battle. With billions of connected devices, how does a specific video find your phone without getting lost in the noise? Every device, from a server in California to the smartphone in your hand, has a unique numerical coordinate. This is your IP address, the foundational postal address of the digital world. The Domain Name System, or DNS, acts as the Internet's phone book, translating names into numerical IP addresses. For efficiency, files are shattered into data packets. These travel through different physical routes, locking together once they reach your specific IP address. This packet system provides the Internet with its resilience. If a single physical cable at the bottom of the sea is severed, the packets automatically find a new route to reach their destination. When data arrives from overseas, it enters the country at a coastal landing station. This is the gateway where ocean cables meet land. The global wholesalers of this data are Tier 1 providers. These massive international companies own and maintain the submarine cables that link the continents. Next are Tier 2 providers, national companies that pay Tier 1 giants to bring data onto land and distribute it across domestic networks. Finally, Tier 3 providers and local cell towers handle the last mile. They convert the fiber optic light into electromagnetic waves that your phone receives. This tiered structure is a commercial hierarchy. Your monthly internet bill funnels money up through these providers to ensure the physical cables under the ocean stay functional. With billions of dollars, massive data centers, and global cables in play, who is the ultimate owner of the internet? You might look to ICANN, the nonprofit that manages domain names and IP addresses. However, ICANN manages the rules of the road. They do not own the road itself. While the business of the internet follows a tiered pyramid, the ownership of the internet is completely fractured. Because the cables, the servers, and the networks are owned by thousands of competing entities across different borders, the hierarchy collapses into a horizontal web. This fragmented reality means that no single corporation or government has a kill switch for the global network. Control is distributed across the entire physical machine. The internet operates as a decentralized machine. If you are ready to claim a piece of it, you can buy a domain, rent server space, and establish your own corner of this global landscape.